so here we go. So we have the unit sphere. We're going to draw a picture of the unit sphere in a second. Oriented outward, let's not forget that. We'll do that. Now we're going to divide it into 8 pieces. Various rules for how we're labeling them. All right, so first of all, let's draw the unit sphere and divide it into 8 pieces. So, for those listening on the recording, I've already given a recommendation that a strategic purchase of an orange can be very helpful here, because then you can have a 3-dimensional model of what we're going to try to draw here 2-dimensionally to limited success. Okay, so let's see here. So then the prime meridian, sort of. Something like that. Now, I was being careful when I drew this. You'll notice that the prime meridian and the equator have to intersect at the x-axis. Right? You got to sort of consciously think about that as you're drawing, and likewise on the backside as well. Okay, and then let's see here. So, see, we have most of our lines drawn here. And, okay, yeah, in fact, I'm just going to go ahead and say that this is all of the lines. I suppose, technically, I could draw the sort of, 90-degree line like that, but it's so close to... I'm just going to say that the horizon line here is that line, and close enough. Okay, so there's our 8 pieces. And let me, just for effect, let me... let me highlight what these 8 faces are. Here's the first one. There's the second one. There's the third one in the back. And then here's the fourth one. Like there. Everybody seeing what we're talking about here? Okay. All right, so now I'm going to clean that up. Okay, so let's see here. The 4 above the 4 quadrants of the XY plane, 1, 2, 3, 4, respectively. Let me draw that. To some extent. Oh, I'm down here. So, oh gosh, this is going to be tough to draw. So. Maybe I won't draw it on here. I'm just going to acknowledge that that's the first one because it's sitting above the first quadrant, etc. And let's just try to remember it because my picture is going to get really ugly. So I'm going to label and use and then erase as needed. Okay. Now the edges, though, I really need to label because we're going to be looking at those a lot. Okay, so the 4 edges in the XY plane, 1, 2, 3, 4. According to quadrant, counterclockwise. Okay, it's a lot to remember. The arbitrary conventions that I'm choosing just so we can have labels down, so we can all be speaking the same language here. Okay, so the 4 edges in the XY plane. There we go. And let me label those all counterclockwise. So. There's the counterclockwise on each of them. And they are called E1, E2, E3. Where am I going to put the E3? I guess I'll stick it right here. E3 and E4. Yeah? Anybody good? All right. Let's see here. Okay. 5, 6, 7, 8 in the ZX plane. Now notice I wrote ZX so that okay, well, so let me do that when I get there. So ZX. So by ZX plane, by having put the Z first and the X second, intended to suggest where you're sort of, which direction is the first one and which direction we're going around in that plane. So in this circle then, right? The edges are going around in that order. So that order, that, and that. And those are, those are E5, E6, E7, and E8. All right, everybody good? Okay, and now, whew, man, it's getting ugly, isn't it? All right, let's see here. Next. 9, 10, 11, 12 in the YZ plane. Okay, well, in the YZ plane, our four edges are, whoa, that was the worst circle I've ever drawn. Going around like that. So this is then E9, E10, E11, and E12. Okay. Everybody on board? Sure would be nice to have an orange. You could do this on an orange, right? You label the X, Y, and Z axes as sort of, pick 3 points on the surface of the orange, and at that point everything kind of works through nicely. Okay, now with all of this labeled, and I guess I'm going to go ahead and say X, Y, Z, just to completeness. Okay. Write out the boundary of each of the 8 pieces as combinations of the edges. Okay, now don't forget this is an outward-oriented sphere, so all 8 of these pieces of surface are oriented outward. Okay, so we're going to have to look at this picture and one at a time start with S1, noticing that it's oriented outward. I've got to visualize now, thumb in the direction of that normal vector. Think of which direction your finger swirls around that normal vector, and then think how those sideswipe up against the boundary. So here's the 3 directions. There's the counterclockwise. There's the, the finger swirl directions. And you can see which 3 edges this is on top of. And what this says is that the boundary of S1 is, well, on the one hand, there's E5 going the correct direction, so E5. Then there's E1 going the correct direction is E1, so I have plus E1. And then lastly, plus E9, because I'm going the same direction as the arrow we've put down for E9. Everybody on board? Okay. And repeat. So let me just do one more. Oh gosh, I hope I can erase this without messing up my... There we go. Okay. Let's do... anybody care? Let's do a hard one. Let's do one of these ones in the back and the bottom. Okay, this is probably the hardest one to visualize. This one... that one back there. Bottom, back left. Alright, so that's sitting below the 3rd quadrant in the XY plane. And remember, we had a convention for how we were going to label these things. 1, 2, 3, 4 were sitting above the XY plane. Here are the ones below the XY plane. We're looking for the one below the 3rd quadrant, and so that's S7, following the naming convention that's described there. Does that make sense to everybody? This is S7? Okay, so, okay. There we go. Okay. Well, now, be very careful here that the orientation on that piece of surface is outward. So now you've got to visualize your thumb going into the page, right? Because into the page is what is outward away from the ball on that sphere. And now with your thumb pointing into the page like that, notice which way your fingers curl. As seen from where we've drawn this, our fingers go clockwise from our visual perspective here. So let's take a pause on that. Is everybody on board? Now, if we had an orange, right, we would just hold up the orange and say, oh yeah, but you just turn the orange around to where the part that you're looking at is right there, and then you very comfortably stick your thumb like this. Yeah, there you go. Look at the ball, and yeah, right. So feel free to look at the ball. I'm going to make the argument from the point of view of this, of what I've drawn here, because we're recording. But look at our three edges, and I guess I'll write this down over here. So the boundary of S7, we agreed this was S7. Well, E3 is part of it, but look at that. The boundary orientation is going the opposite of the direction of what we've defined to be the direction E3 goes. So it's really minus E3. Yeah? Everybody good? Okay. There's E7, but again, as part of the boundary, it's going one way. The arbitrary label we've put on E7 goes the other way, so this is minus E7. And then E11, but again, going backwards, as it were, and so minus E11. Now, is this consistent with what the ball says? Better be. I mean, it's got to be, but still.
Yeah.
Yeah.
Let's see. This would be going.
So you got a thumb. Yeah, exactly.
This would be going counterclockwise.
Counterclockwise from that point of view.
Yeah.
Okay. Well, much easier to see there and harder to visualize here. Okay. All right. So now we've done 2 of them. There's 6 more. I'll let you guys do those. Yeah. Okay. All right. So that's the first part of the problem. Oh, let me clean up my mess again. Okay, how am I going to erase this without messing up my picture? Very carefully. There we go. Okay. 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 Cool. Okay, now we're going to look at the union of the first 4, you'll notice. The first 4 pieces. So S1, S2, S3, S4, look at that. So that's the entire, it says right here, the upper half of the sphere. Right? And the part 2 here says, let's look at the boundary of that upper half of the sphere. So let's write that down first, and we'll get to what comes next in a minute. But let's write down the boundary of the upper half of the sphere. Okay. Oh, did that have a name? No. Do it over here. So if I look at the, union, I goes from 1 to 4. That union is that entire upper hemisphere. Right? The boundary of that upper hemisphere is, it's just this. Now, let's think about orientations. The normal vector is that way. Thumb, fingers, swirl. It's going to be going like this. All right, so there's the boundary of the upper hemisphere. Everybody on board? And we can write down what that is. It's a matter of writing it down. Again, look at the pieces. So, plus E1. Plus E2, plus E3, and plus E4. Oh, yeah, no worries, yeah. Okay, yeah, sure. Okay, so, everybody happy with that part? So, the question then says, let's confirm that that's equal to the sum of the individual boundaries. So now we've already computed the individual boundaries. These individual boundaries you computed in part 1. Well, you guys are going to compute. All right, we did a couple of them, right? But so you get to look at each of those boundaries from part 1, add up those 4, and confirm that you get the same thing as if you took the boundary of the whole upper hemisphere. So that's just a little bit of arithmetic. I'm going to let you guys fill in those blank. Whoops, hit the wrong button. Sorry. So you're going to add up boundary of S1, boundary of S2, boundary of S3, boundary of S4. Namely, you're going to compute summation boundary SI. That goes from 1 to 4. And you want to confirm that this is equal to that. Pretty good. So this is just, we made the observation in the section that boundaries accumulate. This is just a manifestation of boundaries accumulating, and we did it sort of in the abstract. And this is just a real, concrete example of that working out. Yeah. And roughly speaking, when you do this summation, what you're going to find is that this edge appears twice. That edge appears once as part of the boundary of S1 with a positive orientation, and it appears another time as part of the boundary of S4 with the opposite orientation, and then those cancel. Yeah. Okay. I guess I better hit the eraser here. Okay, so these are going to be hard to... Okay, good. And... missed this one. Okay, cool. Okay, let's see, next part of the question. Okay, so what's the boundary of the entire sphere? Well, we don't even really have to write anything down for this. We take the entire sphere. Where's the edge of the sphere? At what point as you're sailing around the surface of the Earth do you fall off? Don't. There is no boundary on the sphere, right? I attended a math talk one time, and the speaker wrote down, theorem, the boundary of the sphere equals 0, and then he credited as the person who discovered this, Christopher Columbus. Right. Okay. So that's 0. Now, is this equal to the sum of the boundaries of the 8 pieces that make up the sphere? Well, okay. So what you're going to have to do there is you're going to have to take all 8 of these terms here. We wrote down 2 of them, but you got to write down the other 6, right, and add them all up and confirm that they all cancel. And they better cancel, right? Because of course they're supposed to add up to what is the boundary of the entire sphere. Because the boundary of a union is supposed to equal to the sum of the individual boundaries. Yeah.
Could we, using the lower half of the sphere, calculating that boundary, if we added those together, would then create pretty much the same exact thing?
Well, yeah, sure. So you've already computed the sum of the first 4. If you wanted to take the sum of the first 4 that you already know, and then take the sum of the other 4 and add that, then that gives you the sum of the 8 individual. And then, as I think was your point, that's equivalent, of course, to taking the boundary of the northern hemisphere, that we already know this sum is equal to, the boundary of the southern hemisphere, that equivalently the other summation is equal to, and noticing that the boundary of the northern plus the southern is the equator, twice with opposite signs, and it cancels. Yep. Okay. So all this, the whole purpose of this question was to just get your hands a little dirty and play around with how boundaries of pieces of surface actually behave like we described. That they have this accumulating sort of feature as described in the section. It's just an exercise in that direction. Any questions about it? Is everybody happy?
Yeah.
Okay. Good. Okay. Let's see, how long did that take?